This is Algebra 2, Unit 8, Lesson 1 on square root functions. Now, we know that square roots are the inverse of squaring. Basically, when you take the square root of something, so if I take the square root of a, I am looking for what number that was squared that would give me a. That's what a square root is. We are undoing what was squared. So, when we are working out these values, we need to be able to recognize the square root function and what it looks like when you graph it, and their domain and range. Square roots are used a lot in upper level mathematics, so let's take a look at the square roots. Consider the two functions f of x equals the square root of x and g of x equals the square root of x plus 3 minus 2. Okay, now the first one, f of x, we should be able to graph without the calculator. Alright, so if we are going to look at the square root of x, we probably want to use perfect squares. Okay, so I'm going to pick out a couple perfect squares here. What would be my first perfect square that I would probably want to use? I'm thinking probably 0. So if x is 0, what would be the square root of 0? Is 0. Next perfect square would be 1. Square root of 1 is 1. Next perfect square would be 4. The square root of 4 is 2. And the next perfect square would be 9. Square root of 9 is 3. Okay, so if I graph these, 0, 0 would be here. 1, 1. 1, 2, 3, 4, 1, 2 would be there. And then 9, 1, 2, 3 would be right here. And notice it's a curve. And it kind of looks like a sideways parabola because it is. It's a quadratic. All right, so here we go. Now, using your calculator to generate a table of values, graph y equals g of x on the same grid and label its equation. Start your table at x equals negative 10 to see certain x values not in the domain of this function. Alright, so I'm going to grab my calculator, I'm going to go to y equals, and I'm going to put in, exactly as you see it, the square root of x plus 3. Forward arrow to stop the square root, because notice the minus 2 is not under the square root. Alright, and then I want to look at my table. Okay, so if I'm looking back here, if I go to negative 10 in my table, what do I see? I can see in my table that I have a bunch of errors. Now, why is that true? Because if this is a square root, when you're working with these, if this is a square root and you make this negative, you can't have a negative value in the square root. So let's pick some values that we can use. Where can we start? All right, so where is the first one I can start? Probably negative 3, negative 2, and then negative 2, negative 1. So let me graph those. Negative 3, negative 2. Negative 2, negative 1. All right, need a couple more. Let me scroll down. Negative 1, negative 0.586 is hard to figure out. How about 1, 0, 6, 1? Let's try 1, 0, and 6, 1. See what we can do there. All right, so 1, 0 would be here. And then 6. 2, 3, 4, 5, 6, 1 would be right there. So I have another curve that goes like this. So this square root function shifted. Now notice the shift on this. We started here at square root of x, and we ended up with x plus 3 minus 2. All right, this one started at 0, 0. Where did this one start? It started at negative 3, negative 2. All right, now remember our shifting rules that we did with the parabolas? Remember when it was inside the parentheses, it would go left or right, and then outside would be up or down? All right, so inside the parentheses, this means we shifted how? From here to here, we shifted left 3. And then this one, we went down 2. So if it's under the square root, just like in the parabola when we have x minus h squared, inside the parabola it went left and right, it's always the opposite sign. It's going to go to the left 3, and then on the outside it's going to go down 2. So we can graph that immediately if we know the values. All right, so let's state the domain and range of each function below using set builder notation. All right, the domain and range, the x values for the square root of x. Well, the x values here, if we box this in, starts at 0. Does it stop? No, it's going to go on forever. So the domain for this will be the x's such that x is greater than or equal to 0. All right, and the range for this one is also 0, and it goes up indefinitely for the value of y. So it's going to be y such that y is greater than or equal to 0. Okay, now notice that this one shifted. Remember, it shifted 3 to the left and 2 down. So let's look at our domain. Our domain for this one, for the x values, it's going to start here, and it's going to go on infinitely to the right. So it's actually going to start at -3. If you look at your calculator at the table right here, after -3, there is an error. Anything after -3 is an error because that would make the square root negative, which we can't do. So if we have the square root of x plus 3 minus 2, the domain is going to start at x such that x is greater than or equal to -3. All right? Because that's the first place that you can graph without it being an error. Because -3 plus 3 is 0, minus 2 is -2. So 0, -2 would be our first point. All right, now the range for this. The range would be the lowest to highest y value. The lowest y value on this is right here if we box it in. Let me do a different color. If I box it in down like this, the range, the lowest one, would be y equals -2. And it also goes on infinitely because of the arrow on the end. So this is going to be y such that y is greater than or equal to -2. All right, so that's your domain and that's your range. You can see the shift. All right, it went 3 to the left and 2 down, so the domain also shifts 3 to the left and 2 down. Okay, which of the following equations represent the graph shown below? All right, so let's think about what our regular graph looks like. It looks like this: 0, 0, 1, 1, 4, 2, and so on and so forth. It looks like this, going like this. What happened to this graph? Well, let's see. It's going to flip over, and it's also going to shift. All right, which way did it shift? Well, here's the vertex, and the vertex ended up here. All right, so we shifted left 4, and then we reflected in the x-axis, which means we flipped it. We flipped it over the x-axis. All right, so let's think about this. If I'm going to shift to the left, all right, remember up here we shifted to the left up here? Under the square root, it would have to be x plus 4. All right, so that would shift it 1, 2, 3, 4 this way, and it would go up like this, and so on and so forth. It would go up like this. How do we get it to flip down? All right, remember with a parabola, how did we flip it? If the parabola is pointed down, the leading coefficient is negative. So the leading coefficient on this would have to be negative. So that means that the negative would have to be here. That does the flip, and this does the shift. Shift left. So this one would have to be number 1. All right, now as we saw in the first exercise, the domains of square root functions are oftentimes limited due to the fact that square roots of negative numbers do not exist in the real number system. That's with the error stuff that we end up with. All right, so we'll be talking about those later on, but let's be working with real numbers. So which of the following values of x does not lie in the domain of the function y equals x minus 5? So basically, if we're looking for the square root of x minus 5, we want it to be real numbers. Okay, so we want this to equal a real number. So you cannot take the square root of a negative. So let's see what happens. Let's take x equals 6. The square root of 6 minus 5 is the square root of 1, which is 1. That's a real number. Okay, for number 2, the square root of 2 minus 5 is equal to the square root of -3. That is not a real number. So the answer to this should be number 2. You can't take the square root of negative because that's not a real number. We'll be talking about imaginary numbers pretty soon, but for right now, that's not a real number. If you look at the other two, just for argument's sake, the square root of 5 minus 5 is the square root of 0, which is a real number. And the square root of 7 minus 5 is the square root of 2, which is a real number even though it's irrational. Okay, it's equal to the square root of 2. So this one is not a real number because you can't take the square root of a negative. All right, so if we are looking at the graph of this, the square root of x minus 5, the square root of x minus 5, and you look at your graph, oops, sorry, I forgot to reset this. there's my graph. It looks like that. You can see that only the values of x start at 5 and go up. So anything after 5 would make this a real function. Anything other than that will make this not real numbers. All right, now for exercise 4, let's determine the domain for each of the following square root functions. Show an inequality that justifies your work. All right, so if this is an inequality for the domain, whatever is underneath the square root has to be a positive number. So how do we indicate that? Whatever is under here has to be greater than or equal to 0. So if I take x plus 2 and set it greater than or equal to 0, I can solve that. That gives me x is greater than or equal to negative 2. So as long as x is greater than or equal to negative 2, it'll be a real number. If I put negative 2 in here, it'll be 0, which is a real number. And then anything after that, negative 1, 2, 3, 4, whatever, will work. If I plug in negative 3, it doesn't work. So x would have to be greater than or equal to negative 2. All right, so 3x minus 2 for this one under here would have to be greater than or equal to 0. So 3x is greater than or equal to 2. Divide by 3, x is greater than or equal to 2/3. Okay. All right, now 8 minus 2x would have to be greater than or equal to 0. All right, let's solve this for x. I'm going to subtract the 8. And then I have to divide by negative 2. What happens when I divide by a negative? It's going to flip the inequality. So negative 8 divided by negative 2 is 4. So x would have to be less than or equal to 4. All right, so if I plug in 4 here, it's going to give me 0, which works. If I plug in 5, it'll be 8 minus 10, which is negative, so that doesn't work. But if I plug in 3, 8 minus 2 times 3 is 6. 8 minus 6 is 2. That is a real number. So x would have to be less than or equal to 4. All right, let's save the let's work for part of this one. Consider the function f of x equals the square root of x squared plus 4x minus 12. Use your calculator to sketch the function on the axes given. All right, so on my axes, I have the square root of x squared plus 4x minus 12. I'll go to my calculator. The square root of x squared plus 4x minus 12. Okay, and if I go to my graph, it should look like that. Okay, so look at our values that we have here. It starts at 1, 2, 3, 4, 5, 6, negative 6, and positive 2, and it goes like this. 1, 2, 3, 4, 5, 6, and goes like this. And then at positive 2, it would go like that. Now, how do we know those were the values? Well, set up and solve a quadratic inequality that yields the domain of x. All right, so we know whatever's underneath the square root would have to be greater than or equal to 0. All right, now how do we solve the quadratic inequality? Do you remember? We have to factor because we're looking for the zeros. All right, so that would be plus 6 and minus 2. So my zeros are going to be at x equals negative 6 and x is equal to 2. All right, so remember I draw my number line and then I look at negative 6 and 2 should be my zeros. Are they included? Yes, they are, because that's where it's equal to 0, so they are included. So we are looking for where they're greater than or equal to 0, so we are looking for where it is positive. So if I go to my table, I'm looking for where it's positive. So I got to go to my zeros first. There's the 2. There's an error between here. And then negative 6, I can see it's positive here. It's an error here. It doesn't work because it makes it negative. And then after 2, it's going to be positive. So if I go back to here, this is going to be positive, this is going to be negative, this is going to be positive. So it's got to work here to there. So that is the quadratic equation, and that yields the domain of x. All right, so if your domain would have to be x is greater than or equal to negative, or excuse me, less than or equal to negative 6, or x is greater than or equal to 2. That would be your domain for this. Okay, so that is square root functions. Pretty simple, not too bad.